App development process. Although the tasks of developing an app may seem daunting, the process can be distilled into several digestible steps. The steps that I follow will help you get started and guide you in the right direction as you develop your first app. Defining the concept. Every great app starts with a concept. The best way to arrive at the concept is to consider the problem you want your app to solve. Great apps solve a single, well-defined problem. For example, the Settings app allows users to adjust all of the settings on their device. It provides a single interface for users to accomplish a related set of tasks. Here are some key questions to consider when arriving at a concept. Who is your audience? Your app content and experience will differ depending on whether you are writing a children's game, a to-do list app, or even a test app for your own learning. What is the purpose of your app? It's important for an app to have a clearly defined purpose. Part of defining the purpose is understanding what one thing will motivate users to use your app. What problem is your app trying to solve? An app should solve a single problem, well, instead of trying to offer solution to multiple distinct problems. If you find that your app is trying to solve unrelated problems, you might consider writing multiple apps. What content will your app incorporate? Consider what type of content your app will present to users and how they'll interact with it. Design the user interface to complement the type of content that's presented in the app. The app concept doesn't have to be completely polished or finished when you start developing your app. Still, it helps to have an idea of where you're going and what you need to do to get there. Designing a user interface. After you have a concept for your app, designing a good user interface is the next step to create a successful app. A user needs to be able to interact with the app interface in the simplest way possible. Design the user interface with the user in mind and make it efficient, clear, and straightforward. Perhaps the most challenging thing about building a user interface is translating your concept into a design and then implementing the design. To help simplify this process, use storyboards. Storyboards let you design and implement your interface in a single step using a graphical environment. You can see exactly what you are building while you are building, get immediate feedback about what's working and what's not, and make instantly visible changes to your interface. When you build an interface in a storyboard, you're working with views. Views display content to the user. In tutorial basics, you began to define a user interface for the to-do app using a single view in a storyboard scene. As you develop more complex apps, you create interfaces with more scenes and more views. In tutorial storyboards, you'll finish building the user interface for your to-do list app using several different views to display different types of content. You'll learn more about working with views and storyboards to design and create a user interface in designing a user interface. Defining the interaction. A user interface doesn't do much without any logic blocking. After you created an interface, you define how users can interact with what they see by writing code to respond to user actions in your interface. Before you start thinking about adding the behaviors for your interface, it's important to understand that iOS apps are based on event-driven programming. In event-driven programming, the flow of the app is determined by events, system events, or user actions. The user performs actions on the interface, which triggers events in the app. These events result in the execution of the app's logic and manipulation of its data. The app's response to user action is then reflected back in the interface. As you define how a user can interact with your interface, keep event-driven programming in mind, because the user, rather than the developer, is in control of when certain pieces of the app code get executed. We want to identify exactly which action a user can perform and what happens in response to these actions. You define much of your event handling logic in view controllers. You learn more about working with view controllers in defining the interaction. Afterward, you'll apply the concept to add functionality and interactivity to your to-do list app in tutorial storyboards. Implementing the behavior. After you define the actions a user can perform in your app, you implement the behavior by writing code. When you write code for iOS apps, most of your time is spent working with the Objective-C programming language. You'll learn more about Objective-C in the third module, but for now it helps to have some basic familiarity with the vocabulary of the language. Objective-C is built on top of the C programming language. It provides object-oriented capabilities and a dynamic runtime. You get all of the familiar elements such as primitive types, int, float, and so on, structures, functions, pointers, and control flow construct, while, if, else, and post statements. You also have access to the standard C library routines such as those declared in stdlib.h and stdio.h. Objects are building blocks for apps. When you build an iOS app, most of your time is spent working with objects. Object package data with related behavior. You can think of an app as a large ecosystem of interconnected objects that communicate with each other to solve specific problems such as displaying a visual interface, responding to user input, or storing information. You use many different types of objects to build your app, ranging from interface elements such as buttons and labels to data objects such as strings and arrays. Classes are blueprints for objects. A class describes the behavior and properties common to any particular type of object. In the same way that multiple buildings constructed from the same blueprint are identical in structure, every instance of a class shares the same properties and behavior as all other instances of that class. You can write your own classes or use framework classes that have been defined for you. You make an object by creating an instance of a particular class. You do this by allocating it and initializing it with acceptable default values. When you allocate an object, you set aside enough memory for the object and set all instance variables to 0. Initialization sets an object's initial state, that is, its instance variables and properties, to reasonable values and then returns the object. The purpose of initialization is to return an usable object. You need to both allocate and initialize an object to be able to use it. One of the fundamental concepts in Objective-C programming is class inheritance. The idea that a class inherits behaviors from a parent class when one class inherits from another. The child or subclass inherits all the behavior and properties defined by the parent. The subclass can define its own additional behavior and properties or override the behavior of the parent. This gives you the ability to extend the behaviors of a class without duplicating its existing behavior. Objects communicate through messages. Objects interact by sending each other messages at runtime. In Objective-C terms, one object sends a message to another object by calling a method of the object. Although there are several ways to send messages between objects in Objective-C, by far the most common is the basic syntax that uses square brackets. If you have an object some person of class XYZ person, you can send it the say hello message like this. The reference on the left, some person, is the receiver of the message. The message on the right, say hello, is the name of the method to call the receiver. In other words, when the above line of code is executed, some person will be sent the say hello message. Protocols define message contracts. A protocol defines a set of behavior that's expected of an object in a given situation. A protocol comes in the form of a programmatic interface, one that any class may choose to implement. Using protocols, two classes distantly related by inheritance can communicate with each other to accomplish a certain goal, such as parsing XML code or copying an object. Any class that can provide behavior that's useful to other classes can declare a programmatic interface for bending that behavior anonymously. Any other class can choose to adopt the protocol and implement one or more of its methods, making use of the behavior, incorporating the data. After you implement your app's behavior, you create a data model to support your app's interface. An app's data model defines the way you maintain data in your app. Data models can range from a basic dictionary of objects to complex databases. Your app's data model should reflect the app's content and purpose. There should be a clear correlation between the interface and the data, even though the user doesn't interact with the data directly. A good data model is essential to creating a solid foundation for your app. It makes it easier to build a scale up, improve functionality, and make changes to your features. You'll learn more about defining your own data model and incorporating the data. Use the right resources. Design patterns are best practices for solving common problems in apps. Use design patterns to help you define the structure of your data model and its interaction with the rest of your app. When you understand and use the right design patterns, you can more easily create an app that's simple and efficient. You'll learn more about design patterns in using design patterns. As you start implementing your model, remember that you don't have to implement everything from scratch. There are a number of frameworks that provide existing functionality for you to build upon. For instance, the foundation framework includes classes representing basic data types such as strings and numbers, as well as collection classes for storing other objects. It's recommended that, where possible, you use existing framework classes or subclass them to add your own app's features instead of trying to implement their functionality. In this way, you can create an efficient, functional, sophisticated app. You'll learn more about the capabilities of the foundation framework in working with foundation. Often, you'll write your own custom classes as part of your data model. Writing a custom classes gives you control over how you organize the internal structure of your app. You'll learn more about creating custom classes and writing a custom class. Incorporate real data. When you first test your data, you may want to use static or fake data. This way, you don't have to worry about supplying real data until you know the model is assembled and connected properly. After you define a data model that's working properly, you can pour real data into your app. The remainder of this guide takes you through these steps in more detail. As you make your way through the app development process, you learn the necessary conceptual material and then put it to use in the tutorials.